All right, PoA, let's get rolling. Problem 6. Okay, so here is what we're dealing with right now. We got these patterns. We need to find 3 interested patterns, and here's the part most people ignore. You have to provide some explanation of how you know the pattern's right. It doesn't have to be a long-winded explanation. It has to be just something that tells us this is how I found the pattern, or this is what the pattern is. It doesn't have to be crazy, but you'll see what I mean in a second, all right? So first we have to find a pattern if we want to report out about a pattern. So the first thing I'm going to do is just an experiment. The question I'm asking myself is if I'm starting at this 4, and that's what I have right now, what do I do to the number I have right now to get to the number I get next, which is 9? And I'm just going to try something. I don't know if it's going to be right, but my first instinct is it's negative. I'm just going to add 5. And again, that might be wrong. I don't know if it's going to work or not, but I'm just going to try it and then see if it works again. So if I'm at this number right now at 9, if I do the same thing again by adding 5, do I get to the number I need next? Well, 9 plus 5 is 14. I'm kind of onto something here, I think, so we're going to try it again. If I'm now at 14, I want to get to what comes next, which is 19. If I take what number I have now, 14 plus 5, I do get 19. So I have to assume at this point safely that that is going to be the pattern. So if I'm now at 19, I add 5, I'm going to get to 24. If I'm now at 24 and I want to get to the next number, I add 5 again. That's going to be, 29. So if I'm now at 29, I want to get what number comes next. I'm now going to be at 34. Okay. So if I'm looking at this explanation side and it says, well, explanation of how you know you're correct, the explanation can simply be that. If I take the number I have right now and then I add 5 to it, I get the number that comes next. And that seems to be the pattern that is established throughout, and that's a sufficient explanation. Like if you write that on the test, I'll be totally cool with that. All right, so let's try this. So again, same thing. If I'm at, back it up. If I'm at 1 right now, what can I do to 1 to get to negative 3? And again, my first instinct might be wrong, which isn't a big deal. I just go back and evaluate. So 1 down to negative 3, I know I can accomplish by a negative 4. Let's see if that works again. Negative 3 to 9, well, that's actually going to be a plus 12. That's no good. Like, I don't want to try to guess addition and subtraction of different numbers, especially if you look at the next one, it's not going to be negative 4 again. It's going to be like negative 38. So I don't think addition and subtraction in this case is going to work. Okay, and that's okay because my first instinct can be wrong sometimes, and so can yours, and it's not a big deal. So what I'm going to do is go back to 1 and ask myself the same question again, but I'm not going to try using addition. 1 to negative 3, how can I get from a negative 3 from a 1? Well, I know I can get there by multiplying by 3, but since it's a negative sign, I can get there by multiplying a negative 3. So let's just see if that works again. I'm not going to make assumptions. I'm not just going to think in my head. I'm actually going to work it out. If I'm now at negative 3 and I multiply it by a negative 3, will I get a 9? Well, 3 times 3 is 9. A negative and a negative is a positive. It actually does work out. If I think it works one more time, we might be in business. I'm now at a 9. I need to get to a negative 27 times a negative 3. So 9 times 3 is 27. A positive 9 plus a negative 3 is a negative, times a negative 3 is a negative 27. We are good to go, guys. So it seems to me, if we multiply every time by a negative 3, we should get our next 3 terms. Okay. Here's the opportunity. Maybe pull out a calculator. I'm going to go ahead and grab a calculator myself. Okay, so we have 1 times 3 negative. Oh, wrong button, sorry. 1 times 3 make it negative is equal to negative 3. Then it's equal to 9. Equal to negative 27. Next comes 81. Next comes negative 243. And then 729. And again, for the explanation, we don't have to get crazy. If I take the number I have right now and I multiply by a negative 3, I get the number that comes next. And that's sufficient way. I just like to write it that way because it's kind of like a rule if you look at it. Just so to maybe help out a little bit, right? All right, so let's go to the patterns again. All right, so 100 to 50, 25, negative 12.5. So we're dealing with another kind of alternating positive, negative. And I know from my previous experience, that addition or subtraction did not really help out, and so I'm going to try maybe multiplication division. In this case, division, because I see the numbers getting smaller, and since I have a negative every other one, I'm just going to try dividing straight off with a negative. So 100 to 50, well, I cut that guy in half. That's a division by 2. And because there's a positive to a negative, I'm going to try divided by negative 2. Let's see if that works again. Well, if I cut 50 in half, I get 25. It changed to a positive, which means I have to introduce another negative, because two negatives make a positive. So a negative division by negative 2 works again. And I think I'm going to actually use my calculator. Let's go here. So if I put 100 divided by 2 negative, I get, oh, I think I subtracted me. So 100 divided by 2 negative equals, there it is, negative 50. Negative 20, or so positive 25, which is still matching. Negative 12 and a half. Okay, so this should be 6.25. Enter again. Negative 3.125. Enter again. 1.5625. Okay, so we have that. Now let's get to our explanation. It seems like, again, every time we're taking the number we have right now, dividing by negative 2 to get the number that comes next. One last one. We have 842. 842. Well, this is subtract 4. This is subtract 2. That's not going to work. Okay. Let's see. 8 divided by 2. Oh. 4 divided by 2 is 2. So I think if we carry on this division by 2, we'll be in good shape. Okay, so we'll have 2 divided by 2 is 1. Divided by 2 again is a half. That's like 50 cents. Divide by 2 again, and we get 0.25. So that's an alternative explanation. Oh, I'm sorry. That's the explanation with the numbers that works. I did see one student that I want to validate, but first let's get down to this rule. If I take what I have right now and then divide it by positive 2, I get the number that comes next. But I want to talk about one interesting variant from a student. I'm going to erase this part of it because it's no longer applicable. The student, as I was passing by when they were working on it, put this down. I'll put it down in blue. Had 842028. I'm sorry, 024. Which I think is actually a pretty interesting way to do it because they're kind of looking at it as a visual reflection pattern. It's like taking this part of the line and then folding it over there to that side. I think that's a valid reason, but this is where the explanation comes into play. So if you're gonna do it like that, the explanation is probably gonna be like pattern. So pattern by reflection. I think either one are equally good is the way you kind of saw it. All right, let's go on to this one. So the deal with this is that this one is a purely visual pattern, which is why I brought up that visual pattern from the previous one. So if you kind of think about this as being the dot, okay, so there it is again. Well, if you think about what's happened to it, well, I just had one dot above, one dot to the left. And now I have this like weird 3L. So here's that weird 3L. What happened? Well, one at the top, one at the left again. So we definitely have hopefully a sense that this pattern is going to continue. So here is the 3, 2, 3, 1, 3 that we had from the previous step. And we're just going to add one above and then one to the left. So now I have like a 1, 2, 3, 4, 1, 2, 3, 4. Add one at the top, one on the left, so it's like 5 and then 5 up. So we have the 1, 2, 3, 4, 5, 2, 1, and then one to the left and one at the top, and then you got your pattern. So I'm not going to put the explanation down, but this is totally a visual pattern. You're just seeing that you're always taking what you had before, and you're changing a little bit in this case, adding one dot above, one dot below. So that's what I have to say about patterns. Ladies and gentlemen, I will see you in just a few seconds, hopefully.